yesterday. So yesterday we were looking at sort of bridging topics almost. So things that you've done in GCSE that you need to know really well when we're first starting A-level maths, because they're topics that will come up a lot. And often these are some of the trickier areas of GCSE maths as well. So it's another sort of revisit of it at GCSE level and then taking it up to A-level now. Of another topic. So yesterday we looked at rearranging formulae and indices. We're going to have a look at surds today. So surds come up a lot in A-level maths as well, and they're one of the areas that's really worth sort of revisiting before sort of getting on with the full topic. So when we do lots of bridging courses, and lots of bridging topics will sort of include surds. So we're going to work through some surds and then we will have a go at some A-level surd questions. So it's not that we're just doing a GCSE topic, we're doing surds and then we'll look at some A-level questions that are based on surds again. And what you'll start to notice is actually there's not too much difference between GCSE surds and A-level surds. Questions might be a little bit longer, a little bit more complicated, but actually the general rules and the process that we go through with surds stays exactly the same. So what we will start off with is we'll start off with simplifying surds. So we will start off with simplifying our surds. And actually when we're simplifying, surds, we want to keep in mind lots of algebraic terms that we've used in the past and the same ways that we would simplify in algebra. So I'm going to write our first example down and we're just going to go through simplifying surds straight away with an example. So our first one would be to write root 18 in the form k root 2, where k is an integer. So what's really nice about these questions, and we still get them like this at A-level, is we get this little clue here with our root 2. So what we basically want to do is we want to make root 18, which is our surd, we want to make it as small as possible. So the whole idea of simplifying surds is we want to make root 18, make this as small as possible. So nice and basic, we'll start off. So we want to be able to, we need to know our square numbers. So again, this is something you probably know. If you've forgotten your square numbers, it's a great thing to just sort of time to use it to remind ourselves of our square numbers. But our first two square numbers are 1, 4, 9, 16, 25, and 36. So we'll use that. Okay, so we're looking at 18. Well, we know 9 goes into 18 twice, so we want to find our square number that actually fits into this. So we're looking for the square root of 18. So actually, well, 9 goes into 18, so we are going to write root 9, and that goes into 18 twice. So 9 times 2 gives us 18. Okay, so this is what, so we have root 9 multiplied by root 2. Already we can start to see that we're heading in the right direction because we have this root 2 here and this root 2 in the original question. So now we want to do is we want to try and simplify this as much as possible. So we have an integer, we can turn root 9 into an integer. The root number of 9 is 3. So we would have 3 multiplied by root 2, which the same as in algebra, if we wrote 3y, which means the same as 3 times y, 3 times 2 root, instead of writing that, we can actually just write 3 root 2. And that would be as simple as we can get this surd. So we have our k being an integer, our k is 3, we have root 2 here, and that would explain our first surd. So we're going to have a look at another example now. So this one, again, we're just simplifying again, and we are going to write root 80 in the form k root 5. So again, we've got this k in there. We've got this root 5, which is going to be a clue. And the same rules apply, and it's going to be where k is an integer. Is an integer. So we know our we know our square numbers again. So if we look at our square numbers, we have got 1, 4, 9, 16, 25, and 36. So whilst we're looking at them, there could be two ways that we could actually get to root 80. What you end up doing is the more you do surds and the more we learn roots and square numbers, the more that we sort of go, oh yeah, this number goes into that. So first way that we could get there would be able to be doing 16. So we could have root 16, root 5. So what I'm going to do is I'm going to explain it actually using, we can use 16 or we can use 4. So I'm going to use 4 first, and I'm going to explain why if we used 4 first, this wouldn't be the simplest. So to get root 80 from 4, we would have root 4 multiplied by root 20, and that would give us root 80. If we were then to go and simplify this, the square root of 4 is 2, and the 20 would stay the same. That's not the simplest or the smallest we can make it, and we know that straight away because this 20, we've got root 20 here, and in the question we have root 5. So we know it can't actually be 4. So let's look at root 16. Okay, so 16. 16 goes into 85 times. So we've got root 16 multiplied by root 5. The square root of 16 is 4. So we've got 4 times by root 5. Simplify that again like in algebra, and we've got 4 root 5. Again, this is where you want to remember to be doing things like underlining, so that when we're doing lots of working out, surds, we want to show our working out, we want to show our process. If we underline our correct answers, then it makes it really clear which ones are our answers that we want to show. So that was another example of simplifying a surd. So I'm going to go through probably about 9 or 10 different examples. Then what I will do is I will send you after this a worksheet to go through that has a set of simplifying surds, and then another worksheet that will have arithmetic with surds, so addition, subtraction, multiplication, and division. So we're just sticking with simplifying. I know this is quite basic back from GCSE, but it's really good to actually go over it right back at the beginning and get that really strong understanding. So our third example, we are going to write 3 to the power 3 root 20 in the form k root 5, where k is an integer. So this time is an integer. So this time, rather than just having a surd, so for example, root 80, this time we've actually got an integer with a root. So we do exactly the same process, and actually what we're going to do to start off with is we ignore this number 3. So we're just going to sort of set the number 3 aside for a minute, and we just look at root 20. So we go through exactly the same steps as before. So we've got root 20. Okay, so square numbers that go into 20, 4 does, so it would be 4, root 4, 4 goes into 20 5 times, so we've got root 4 multiplied by root 5. So like, okay, so we've got these two root numbers together. How do I make How do I make it smaller? Square root of 4 is 2. 2 multiplied by root 5, obviously we would get 2 root 5. But we have to remember we have this 3 back at the beginning. So we've got this 2, but we're not financed here because we've got this 3 up at the top. So what we're going to do is we're going to take this 3 from the top and we're going to multiply it by 2, because what we're saying is we've got 3 lots of 2 root 5. So we've got 3 lots of 2 root 5. So all we have to do is multiply 3 by the 2, which would give us 6 root 5. And that would be our correct answer for that one, 6 root 5. This time what we're going to do is it's a little bit similar actually to the ones that we did at the beginning, but we'll have another look. We're going to, oops, my pen's gone a bit strange. We're going to write root 90 in the form k root 10. K root 10. So 90 square numbers that go into 90. Well, we know 9 does straight away, so we can have, we can have root 9 multiplied by root 10. Square root of 9 is 3, so we will have 3 multiplied by root 10. Simplify that like in algebra, and we have 3 root 10. So again, we've simplified it like in algebra and got it down as small as possible. Next one I'm going to show you is one that people could come up with different answers. And again, this is why we need to again look at what's given to us in the question really, really clearly. And this is what shows us how it's the simplest. So for this question, you are going to write root 32 in the form k root 2. So again, we're going to break it down. So actually what lots of people go is okay, square numbers, what square numbers fit into 32? First one most people come to is 4. We go, oh yeah, 4 fits into 32. So we go, okay, so we've got root 4. 4 goes into 32 8 times. So we have root 4 multiplied by root 8. If we simplify that, square root of 4 is 2. So we would have 2 root 8. But this can't be correct because here we've got root 8. In our question, it's root 2. So this is not the correct answer. So it can't be 4. So what other square number fits into 32? Another square number that we can get into 32 is 16. So let's look at this. So we go, okay, 16, root 16. 16 goes into 32 twice. So we've got root 16 multiplied by root 2. The square root of 16 is 4. So we would have 4 multiplied by root 2. Simplify that again, and we have 4 root 2. And that would be your correct answer. Next example, we're going to write, and lots of them, as you see, they become very repetitive, become very similar. So the more confident we get with surds, the better we are. If you're doing this at a later point, you can read the questions, pause it, have a go, and then look at the answers. It's up to you how you do this. So we have, write 2 root 18 in the form k root 2. So again, we're going to ignore that 2 right at the beginning for now and just deal with root 18. So we've got root 18. What square numbers fit into 18? Well, 9 does. So we will have root 9. 9 goes into 18 twice. So we'll have root 9 multiplied by root 2. The square root of 9 is 3. So we would have 3 multiplied by root 2. And then we bring in our 2 again. So we're saying we've got 2 lots of 3 multiplied by root 2. So 2 times 3 would give you 6 multiplied by root 2. Simplify that down again, and we've got 6 root 2. I do a couple more. These ones are now officially A-level questions. You won't actually notice hardly any difference between them, but I'm just going to write a couple of them out again. And then we'll spend a bit of time at the end looking on some more A-level ones. So write 3 root 40 in the form k root 10. So this is quite a nice question. So again, straight away, we're ignoring that 3, dealing with a 40. Square number that fits into 40 is 4. 4 goes into 40 10 times, so root 40 multiplied by root 10. Square root of 4 is 2. Don't have an integer for square root of 10, so that's fine. So we'd have square root of, so we'd have 2 multiplied by square root of 10. Obviously, we have to remember to multiply our 3 by our 2, so we would have 6 multiplied by root 10. So 6 root 10 would be our correct answer. This time, we're going to have a look at one that's really, really similar. We're going to write root 50, and we're going to do it in the form k root 2, and k again is an integer. So 50, we know our square numbers. We know 25 is a square number, so we can go in straight away and say root 25 multiplied by 2, that would give us root 50. And can we do the square root of 25? Yes, we can. So square root of 25 is 5. Can't simplify root 2, so it'd be 5 root 2. And finally, for simplifying, we have got this one. So we have got 8 root 8, and it can be expressed as a form, in the form m root 2. So m is a positive integer again, so we're going to express 8 root 8 in the form m root 2. So same rules as before. I'm going to ignore this 8 at the beginning, just deal with 8. So a square number that would fit into 8 would be 4. So we're going to have root 4. 4 goes into 8 twice, so we're going to have root 4 multiplied by root 2. Can we simplify down root 4? Yes. Well, the root number of root 4 is, square number of root 4 is 2. Can't simplify down root 2, so we would have 2, 2, but that's not right. I'm going to explain why now. So if we just stop there, we'd have an issue. Oh, let's get our root 2 back. We'd have an issue because we've ignored this 8 at the beginning. So we need to remember to do 8 multiplied by 2. 8 multiplied by 2 is 16. So we would have 16 root 2. And that would be our correct answer. So that's simplifying surds. We might look at a few more complicated ones just towards the end. We'll leave that one where it is now. We're going to look at now adding and subtracting surds. When you're adding and subtracting surds, they'll often be written like this. It will often say something like simplify root 40 plus root 90. Okay. We can't just add these numbers together. If we compare it to algebra again, if we have 4x plus 4y, you know that is the simplest that can get. We cannot do anything else with that to simplify it anymore. So 4x plus 4y is as simple as you can get. However, if you have 4x, add 4x, we can then go and simplify that, because actually we've got one lot of 4x another lot of 4x, so we add our 4 and our 4 together. That would give us 8x. So the same concept holds for surds. So our base number has to be the same for us to add together. So if this base number was the same, which it's not, but if base number is the same, you can add together. Obviously, we don't have that here, so we're going to need to do something else. We're going to have to get a base number that is going to provide them with being the same. So actually, we're going to start simplifying them again, like we were doing before. So let's look at 40. 40, we know straight away 4 goes into 40. So it would be root 4. 4 goes into 40 10 times, so it would be root 4 multiplied by root 10. So that's our root 40 dealt with for now, partially. And we'll come back to it properly in a minute. Well, actually, we can simplify it down. We'll simplify it down first. So we can simplify down root 4 to 2. Root 10, we can't simplify down, so we've got 2 root 10. I'm going to put my addition sign here, because this is the part now we're going to look at root 90. So root 90, well, again, a square number that goes into 90 is 9. 9 goes into 90 10 times, so we'll do root 9 multiplied by root 10. Can we simplify root 9 down? Yes. We have 3. Root 10, no. So we've got 3 root 10. So now we can look at it. If I write this up in another colour at the side, so our equation now stands at 2 root 10 plus 3 root 10. Can we simplify this more? Yes, because now our base numbers are the same. Before we couldn't do anything. We couldn't add 40 and 90 together because they were different base numbers. Now we've got 10 and 10. They're our same base numbers. So what we're basically saying, it's like this algebraic equation. We've got 2 lots of root 10, 3 lots of root 10. So together we have in total 5 lots of root 10. And that would be our correct answer. So another example. We're going to write root 27 plus root 48 in the form, and so this is where we have some of the overlap, where we have some of the, we're getting told what form to write it in. It's nice, it helps us, it tells us what we want, in the form a root 3, and a is going to be an integer again. We do exactly the same as we did the first time. Deal with root 27 first. We know that 9 goes into 27, so we're going to have root 9. 9 goes into 27 3 times, so we're going to have root 9 multiplied by root 3. Can we simplify root 9 down? Yes, we can have 3. Can't simplify root 3, so we've got 3 root 3. Let's look at 48. Okay, 1, 4, 9 doesn't fit in, but 16 does. So we can have root 16. 16 goes into 48 3 times, so we will have root 16 multiplied by root 3. We can simplify root 16 down to 4. Can't simplify root 3, so we've got 4 root 3. Oh, and look, we've got this equation now where we've got both of our base numbers exactly the same, so we can just add them together. So our answer would be, to simplify it, we've got 3 lots of root 3 and 4 lots of root 3, so together we would have 7 root 3. This time we're going to simplify root 45 plus root 125 minus root 20. So this is a bit slightly more complicated because we've got 2 different operations taking place here. I'm going to do exactly the same thing we've done every single time. We're going to simplify each root down on its own first. So looking at 45, the square number that will fit into 45 is 9. So we'll start off with that. So we've got root 9. 9 goes into 45 5 times. So we've got root 9 multiplied by root 5. 9 can simplify down to 3. Can't simplify root 5. So we've got 3 root 5, 45. Okay, let's look at 25 now. Sorry, 125. So 1, 4, 9, 16, 25 does fit. So got root 25. 25 goes into the number 125 5 times. So we've got root 25 multiplied by root 5. Simplify root 25 down into 5. And root 5 we can't do anything with, so we've just got root 5 on the end. I'm going to add in our operation symbols from the original equation now down here. But we're not going to do anything until we've done this final root 20. So let's simplify root 20. 4 goes into 20. So we've got 4 goes in 5 times. So we've got root 4 multiplied by root 5. We can simplify root 4 to 2. Can't simplify root 5. And now our equation looks like this. Oops, let's get back the same colour. We now have 3 root 5 plus 5 root 5 minus 2 root 5. Obviously, that equation you can do really quickly in your head, but I'm just going to break it down just so we can see what's happening about each process. So 3 root 5 at 5 root 5, we would be at 8 root 5. Then we're going to do minus 2 root 5, which obviously will take us then to 6 root 5. And that would be your final answer, 6 root 5. So that is what we do when we've got two different operations going on. Again, just going to simplify each of the roots, then we'll have so we've got all the same base numbers. If we've got the same base numbers, then we can actually do the addition or the subtraction together. I'm going to show you a couple more examples of basic arithmetic with surds. So we are going to simplify what one, I've just forgotten which one I've just done now. 6 root 5. Okay, so we're going to simplify root 3 plus root 12. So I've got root 3 plus root 12. Well, we can't simplify root 3 anymore, so we've just got root 3. You could put a 1 there. We know it means 1, but if it helps you to remember, you can put a 1 there, but it's root 3. 12, can we simplify 12 down? Yep, we can get 4. What I'm going to do for 12 over here actually. So we can get root 4. 4 goes into 12. 4 goes into 12 3 times. So root 4 multiplied by root 3. Can we simplify this down? Yeah, we can turn it to 2 root 3. Let's add this to the equation. So we've got 1 lot of root 3 plus 2 lots of root 3. And our answer to that would be 3 root 3. And it's important to remember that this is equal to 1. That's the biggest error with these questions, is that people forget that that is equal to 1. So our next example, we're going to simplify 20 plus root 125. What you'll find is the more that you do surds, the more you get used to them, and the more we're happy with our root and square numbers, the less that we have to sit and work out which number goes into which. It's a little bit quicker and snappier straight away. 20, we'll deal with 20 over here. I'm going to deal with 20 first on its own. So we've got root 4, because 4 goes into 20, 4 goes into 20 5 times. Simplify that down, we've got 2 root 5. Deal with 125 over here. Or from before, we know that 25 goes into 125 and it goes in 5 times. So we're going to have root 25 multiplied by root 5. So we end up with this as our equation. Sorry, then we can simplify this down to 5 root 5. So we've got the same base numbers now. Because we've got the same base numbers, we can add our integers together and we would have 7 root 5. Having a look at just a couple of subtractions now. So we have got root 45, take away root 20. Root 45, 9 goes into 45, 9 goes into 45 5 times. Root of 9, 3, 3 root 5, 20, 4 goes in 5 times. Simplify this down. So we've got 3 root 5 minus 2 root 5, which would just give us root 5. We don't need to write 1 root 5 because we know this just represents one whole. And that'd be our correct answer for this one. And I have another look at one where we've got a combination of addition and subtraction. So this time we're going to simplify 75, root 75 plus root 27 minus root 48. Deal with it exactly the same way. So we're going to break up the 75 and simplify 75 first. So square number goes into 75 is 25. So we're going to have root 25 goes in 3 times 3. Simplify that down to 5 root 3. 27, 9 is square number goes into 27. It goes in 3 times. Simplify this down and we've got 3 root 3. Put in our operation here. And our final one, 48. We've done 48 a couple of times now. We know that 16 is a square number that goes into 48. It goes into 48 3 times. So we've got root 16 multiplied by root 3. We can simplify this part down to 4 root 3. Add in our operation. Let's go this stage by stage. So we've got all the same base numbers, so we can just add our integers together or subtract them. So we have 5 root 3 plus 3 root 3 would take us to 8 root 3 minus 4 root 3, which would give us a final answer of 4 root 3. Two more examples on this section. We've got root 27 plus root 3. We can simplify root 27. 9 goes into 27, so we've got 9 goes into 27 3 times. So we've got root 9 multiplied by root 3. We can simplify 9 down to 3 root 3. Cannot simplify root 3 down, so we've got 3 root 3 plus root 3. In total, we've got 4 root 3. And our final example, we're going to use some integers with this one. Got 2 root 5. I'm going to add root 20. So again, we're just going to look at them. Can we simplify them? Okay, can we simplify root 5 down any further? Nope. So that's going to stay exactly the same. So we've got 2 root 5 at the beginning of our equation. Okay, root 20, can we simplify that? Yes, 4 goes into 20. It goes into 25 times. So we've got root 4 multiplied by root 5. That can become simplified down into 2 root 5. So we've got 2 root 5 plus 2 root 5, which will give us 4 root 5 as our final answer. So the last little section on surds that we're going to recap is multiplying surds. Multiplying surds is, again, really similar to when we're looking at addition and subtraction, but I will talk it through with you. So we're going to simplify root 5 multiplied by root 5. So we have two base numbers the same, so we don't actually need to do anything complicated here. we can just do 5 multiplied by 5, which would give us the answer of root 25. This wouldn't be the final answer because you've been asked, I haven't actually wrote it on, but you've been asked to simplify root 5 multiplied by root 5. Root 25, yeah, it's simpler, but actually we know what root 25 is. We know that root 25 is 5, so that would be our simplified answer for this one. Here's a different example. I'm going to make sure I write simplify on this time. So we're going to simplify root 15 multiplied by root 3. So what we're going to do is we're just going to multiply those two numbers together again. So 15 multiplied by root 3. So root 15 multiplied by root 3 would give us root 45. Is root 45 as simple as we can get? No, we can actually make this simpler. So what we're going to do is we'll look at exactly the same as we were doing before. How can we make this more simple? What square number goes into 45? We know that 9 goes into 45. So we've got root 9. 9 goes into 45 5 times. Root 9 multiplied by root 5. Simplify this again to 3 root 5. So we're just building up the skills here. And another example. Oh, it won't let me do the whiteboard. 1 second. Save the whiteboard. Clear all drawings. Oh. You knew I could only have 20 pages. All right, I've played it. That's fine. We're going to simplify this time 2 root 3. I'm going to multiply that by 4 root 5. Okay, so what first thing that we do with this is we're going to ignore the integers again like we did before, and we're just going to deal with our base numbers here. So we're going to multiply 3 by 5, which would give us root 15. And then we are going to multiply our integers together. Oh, that should go to 4. So 2 multiplied by 4 would give us 8. So your final answer would be 8 root 15. We're going to have a look at them with brackets as well in a second. So a couple more examples without brackets, and then we'll go on to brackets. So we've got 3 root 6. I'm going to multiply that by 2 root 3. Again, 6 times 3 will give us root 18. 3 times 2 would give you 6. Well, actually now, can we make this simpler? Yeah, we can. So we're going to ignore the 6 for a second. And we're going to simplify our 18. So actually 18, we can simplify that. 9 goes into 18. So we've got root 9, goes in twice, root 2. Simplify that down to 3 root 2. Now, the answer is not 3 root 2 because we have to remember we've got this integer here and this one. So same as before, when we multiply them up here, we're going to multiply them again here. So we're going to do 6 multiplied by 3, which would give us 18 root 2. So we're going to multiply these two numbers together. Another example is, let's do root 7, root 7. Don't know why, these ones always go a little bit strange with people. So if you've got root 7 multiplied by root 7, 7 times 7 equals 49. Obviously, we can simplify that because we know root of 49 is 7. Don't know why, but those ones often always go wrong. And this is our last. Is this one our last? We'll do 2 more. 2 more multiplication examples and then look at expanding brackets. So we've got 2 root 7. And we're going to multiply this by 5 root 3. Again, we're going to multiply our base numbers together. So 7 multiplied by 3 would give us 21. So we've got root 21. 2 multiplied by 5 will give us 10. Can we simplify 21? No. So our answer is 10 root 21. So now we're going to look at expanding brackets. So you'll get a question that will say something along the lines of expand, and what is our example here? We've got root 6, 5 plus 2 root 2. And we're going to deal with this exactly the same as we would expanding brackets in algebra. So to start off, we're going to do root 6 multiplied by root 5, which will give us 5 root 6. Then we're going to do root 6 multiplied by 2 root 2. The whole number, the integer, nothing happens to that because we have no whole number here, so we're just going to have 2 again, but we've got root 6 multiplied by root 2, which would give us root 12. That isn't our equation finished, okay? Because now we can look at it and go, can we simplify this anymore? What else can we do with this? So looking at 5 root 6, can't really do anything with that. So let's look at 2 root 12. So actually 2 root 12, we can do stuff with that. So let's do that on the side. Let's simplify that over here. So 2 root 12, well, 4 goes into 12. So we've got root 4 multiplied by root 3. Simplify root 4 is 2. So we've got 2 multiplied by root 3, so we've got 2 root 3. But we have 2 lots of root 12 over here, so we're going to need to do 2 multiplied by 2 root 3, which will give us 4 root 3. So now our final answer will be 5 root 6 add 4 root 3. We can't do anything else because our base numbers here are different, so we can't add any of them together, and this would be our final answer. Another example would be one like this. So we have got root 3, and we've got root 3 again, minus 2 root 5. I'm going to go through the same process as before. So I'm going to multiply root 3 by root 3, which will give us root 9. Then we're going to multiply root 3 by minus negative 2 root 5. So we're going to put our negative in. We're going to leave the 2 because nothing's going to happen to our 2. We're going to do 3 multiplied by 5, which will give us 15. So we've got 9 minus 2 root 15. Then we look at them. Can we simplify them? Yeah. Okay, so 9 can become 3. 2 root 15 we can't simplify, so it would be 3 minus 2 root 15. So this is, you can start to see the process of expanding the brackets. It's not too complicated. I'm going to go through a couple more examples, and then we're going to go on to double brackets, expanding some double brackets, just to make it a little bit more different. Clear all drawings. So example I'm going to use now is this one. We've got root 3 multiplied by root 6 plus 2 root 3. So root 3 multiplied by root 6, well, that would give us root 18. And root 3 multiplied by plus 2 root 3, that's going to give us plus 2 root 9. Can we simplify these down? Yes. We're looking at them. Can we do much with them? Yep. So let's have a look at this process then. So root 9 would give us 3. But we've got 2 lots of root 9, so we're going to do 2 times 3, which will give us 6. 18, root 18, can we simplify root 18 down? Yes, we can simplify root 18 down into 9, multiplied by 2. Can we simplify this again? Yes, we can. We're going to simplify this to 3 root 2. Oops. So our final answer would be 3 root 2 plus 6. And that would be our final answer. Just going to have a little look now at expanding double brackets. So we'll jump straight in. Same process as expanding single brackets. So we've got 3 plus root 5. Right, 3 minus root 5. So we're going to start off like this. We're going to do 3 multiplied by 3, which will give you 9. 3 multiplied by negative root 5 will give you 3 negative 3 root 5. There's nothing to multiply together there. Don't know what's happening to this anymore. Then let's look at this root 5. So root 5 multiplied by 3 will give us positive 3 root 5. And then finally, root 5 multiplied by negative root 5. Same rules as algebra, a negative and a positive multiplied together will give you a negative number, which will give you negative root 25. Then we can look at these numbers and go, okay, can we simplify these more? Yes. Let's go straight away. Can't actually do anything with 9, so let's leave 9 as it is. I don't want to actually change 3 root 5 and 3 root 5 because they're going to actually be quite nice to add together because they have the same base numbers. Can't simplify them anyway. But can we simplify root 25? Yes, we can simplify that down to 5. So now we've got an equation we can look at. Can we simplify this more? Let's deal with the integers. Yes. 9 minus 5 will give us 4. Minus 3 root 5 plus 3 root 5, they're just going to cancel each other out. So these are going to cancel out. So we end up with our final answer just being 4. Because the 3 root 5, negative 3 root 5, adding the 3 root 5, cancel each other out. So we're just left with 9 take away 5. So our next example, using double brackets, would be this. Got 2 plus root 3, 2 plus root 3, and 5 minus root 3. So what's going to happen here? Same again. So 2 multiplied by 5 will give you 10. 2 multiplied by root 3, negative root 3, will give us negative 2 root 3. Root 3 multiplied by 5 will give us positive 5 root 3. And then root 3 multiplied by root 3 would give us negative root 9. Simplify that down. Actually, we don't want to change anything on this apart from, and we can't simplify anything apart from our root 9 at the end. So that would become 3. Then can we simplify this down even more? Yes. So let's deal with the integers first. We've got 10 take away 3, which would give us 7. And then we can look at our 2 roots. So we've got negative 2 root 3 plus 5 root 3, which would give us a positive 3 root 3. That'd be our answer to that one. Another example, this time we're going to add in square. So this question is 2 plus root 5 squared in the form, so this is quite nice, it's given us a clue again, a plus b root 5, and a and b are our integers. So we're just going to expand the brackets again. So obviously you don't need to do this in an exam, but I'm going to just draw it all out so you can see it. So we've got 2 plus root 5 multiplied by 2 plus root 5. So obviously that's all that is meant by the squared symbol. So 2 multiplied by 2 is going to give us 4. 2 multiplied by root 5 is going to give us 2 root 5. Root 5 multiplied by 2 is going to give us 2 root 5 again. And then root 5 multiplied by root 5 is going to give us root 25. The only one we can simplify so far is root 25 at the end. And that can get simplified down into just 5. And look at the equation. Okay, so deal with my integers. 4 plus 5 is 9. Got plus 2 root 5 plus 2 root 5 gives us 4 root 5. So 9 plus 4 root 5 would be our answer for that one. So that's quite a nice one. I'm going to just go through a couple of more slightly difficult ones now. I'm just going to pick out two actually that are a little bit more difficult. So we're going to do this one as one of our last ones. So we've got 7 plus 2 root 3 with 2 minus 3 root 6. 7 multiplied by 2, we've got 14. 7 multiplied by root 6, 7 multiplied by negative 3 root 6. So here we're going to multiply our 7 by our 3. So we're going to get 21. So we're going to get negative 21 root 6. Then we've got 2 root 3 and multiply that by 2. So 2 times 2 is 4. So we've got 4 root 3 and then finally 2 root 3 multiplied by negative 3 root 6. Again, positive and negative, it would be a negative number. 2 multiplied by 3 will give us 6. Actually, we've got 2 roots to multiply together as well. So we've got 3 times 6, and that will give us 18. So now we're going to look at them and go, okay, can we make these any simpler? Can't do anything with 14, so 14 is going to stay the same. Can't simplify 21 root 6, so that's going to stay the same. Can't simplify 4 root 3, that's going to stay the same. But actually, root 18, we know root 18 is 9. So what we would have over here is we would have 9 multiplied, root 9 multiplied by root 2. Simplify that down, we would get 3 root 2. Oops, that's 3 root 3. We would get 3 root 2. But we have to do 6 multiply by 3, because obviously we have those 2 integers here in play. Not that integer, sorry. So we have this integer in play and this integer in play, so we need to multiply those 2 together. So we'll do 6 multiply by 3, which would give us 18. So it would give us 18 root 2. So this would end up at this point 18 root 2. So this would be our final answer. And I'm going to talk it through again. We've got 14 minus 21 root 6 plus 4 root 3 minus 18 root 2. And we can't simplify that any further than what is given. The last one I'm going to do is this one. So we've got 3 plus root 5 and 5 plus 3 root 2. So 3 times 5 would give us 15. 3 times 3 root 2, well 3 times 3 is 9, so we've got 9 root 2. Root 5 times by 5 will give us 5 root 5, and then finally root 5 multiplied by 3 root 2 would give us 3 root 10. Can't simplify that any further, and that is one that's done.